In this video, what I'd like to now do is talk about how to develop options, both application options, but also methodology options in R, Python, and Excel. By the time you get to this phase of the strategic planning process, you will have already done quite a bit of work. You will have done an objectives workshop to know what you want. You will have looked at all of the data that you already have, plus you would have looked at new models and frameworks to find even more data. After you've done that, you'll sit down and say, okay, let's attack the problem. And you have two basic questions. One, what algorithms am I going to use? It turns out that the choice of that is relatively easy. The harder part is, once you've done steps 1, 2, and 3, you will realize now at step 4 that maybe the applications I first envisioned aren't enough. Maybe I can be broader in my scope. Maybe I should be more narrow in my scope. So the application choice actually becomes critical here, because the application choice, the final application, will largely drive your algorithm or methodology choice. So I'm going to emphasize in this video application choice. Then algorithm choice comes right after that. Okay, in order to choose the applications that you want your teams to focus on, what I'm going to suggest are 6 workshops. Those 6 workshops will then lead to more evaluations of particular projects. Those projects will then in turn lead to a number of supervised machine learning techniques. The first workshop is rather straightforward. You take the equation from the first video on objectives, you write it on a piece of paper, and then simply brainstorm. The reason we revisit the equation now is, after you've done a data audit and modeling, new ideas may crop up in the application space. Can artificial intelligence help us expand geographically by using algorithms to perhaps translate the materials we have in multiple languages that can span the globe? Or perhaps can we use artificial intelligence to resegment the market, to find new clusters of customers we haven't already approached? Or maybe we can use artificial intelligence to improve our product portfolio. Maybe we can use algorithms to create digital products. We can also consider whether algorithms or artificial intelligence can help us in our pricing, creating complex tariffing structures. Or maybe we can use algorithms to reduce our marginal cost, using robots instead of humans to deliver products and services. We might also want to think about using algorithms to help expand the units that we actually sell by perhaps optimizing our marketing or other activities. Finally, we might be able to use algorithms or AI to reduce our overall fixed cost structure, the overhead of our organization. The first workshop might come up with a number of ideas that one can do to actually improve or increase profitability. Sometimes using this equation can be a bit intimidating, so you might want to consider the second workshop. This is called a life cycle analysis. Basically, over time, products eventually mature. And if my product portfolio, represented by the red X's, is at that mature phase, I'm going to need to brainstorm what can I do when I'm at that phase of the product life cycle curve. No matter what I choose to do, I have to make sure that pi goes up. A number of guru books have been written about this problem. Let me summarize all of them in the following list. The first option you can do is simply buy arrival. What that allows you to do is increase your price, perhaps drop your marginal cost because you're a larger company, and reduce your average fixed cost per unit. Therefore, pi goes up. Another thing you can do is simply drop F, cost cutting. Now, to make it more palatable, often people will call this a Delta Force 1 project. Artificial intelligence can help you drive down those fixed cost structures. The third option is maybe stretch your current product or extend it. This is what Toyota did, for example, by launching Lexus, using your company as a platform to launch another life cycle in another product area. The literature has also talked about options about innovation, start a new growth curve, or perhaps acquire a company who is already growing, maybe approaching venture capitalist or private equity firms looking for opportunities for growth. Finally, you can go global. Simply go international. As you can see, all I've done is reworded the equation by using more generic terms that might be helpful in a brainstorming workshop. The key here is to focus on whether artificial intelligence actually has a role to play. If it does not, then stop. If it does, then you can proceed with algorithms and methodologies we describe later. The third workshop I'd like to call a Killer Ideas Workshop. This is where you get in a room with your management team, your development team, and you brainstorm. Often you'll be facilitated by a consultant who will summarize the findings on a few pages. Here's the basic idea. You start with all the pain points that management is concerned with, all of the KPIs that they want to address or the problems they want to solve. And then you ask yourselves, today we're in the world of brick and mortar. What will the future look like? What's going to happen next? Let's use encyclopedias as an example. Suppose I'm a publisher of encyclopedia and I want to have a Killer Ideas Workshop. I'd start with the arc of history, going way back. In the good old days, we used to talk to each other. There were encyclopedias, there were CD-ROMs, there was Wikipedia. Okay, but what's after Wikipedia? What's next? By brainstorming next generation applications, often a number of cool ideas might come out of this workshop, maybe on a post-it note stuck on a wall. The idea is to get all of the intelligence of your management out on the walls and transcribed to a few pieces of paper. Again, we're doing this after we've done data analytics and modeling because maybe there'll be some new ideas that are inspired by that new data and those models. A small piece of advice. Before people attend the workshop, ask them to do a few internet searches where they take the topic of interest to the management and simply add the word artificial intelligence or machine learning. By doing so, they'll learn what other companies may have thought of as cool application areas or data that might need to be predicted when you start doing applications. Now, the previous workshop was pretty good. People really enjoy it. It's a lot of fun. But the problem of it is, maybe your management and your development team don't have the best ideas in the world. Workshop number 4 is called a co-creation workshop. Often people will call this customer-centric design. Here, it's not the pain points of the management you're worried about, it's the pain point of the end users. You bring them into a setting with a lot of preparation up front and have them create the applications of the future. For example, students may be complaining that professors are just not interesting to listen to. Is it possible that they could create, using their imaginations, a robot that could replace a professor? Again, we want to have a consultant there who might take notes while the brainstorming session is taking place. One piece of advice: if you have the opportunity, invite the developers, the engineers, to be with the customers in the same location. I did a number of projects in Uganda where I flew in my development team and we sat down with farmers to help develop mobile apps where they could get weather, crop tips, etc. By co-designing the application that actually affected the algorithms we ultimately deployed. Okay, so now we've been able to access the ideas of both the management and the customers. But what if you really want to think out of the box? I would strongly recommend you read the work of Chan Kim and René Mauborgne. They have come up with this idea they call Blue Ocean Strategy. Let me do a short summary. It begins with a workshop where you list all of the attributes of existing products or services. Let's consider, for example, a circus. The attributes of a circus include animals, opera, ballet, stories, and seats. And what you do is you evaluate different competitors in that space on a scale. Let's just say 1 is low and 10 is high. And then we look at different competitors in that space. A traditional circus has a lot of animals, pretty high. They have very little opera, very little ballet, very little storytelling, but they do have seats. If we look at Cirque du Soleil, you have very few animals. We have opera, we have ballet, we have stories, and we have seats. If we had virtual reality circuses, they would have animals, operas, ballets, stories, maybe no seats, and perhaps they would have an artificial intelligence, machine learning based robot. In other words, Cirque du Robot. What you've noticed is we've taken existing ideas and applied the Eric principle. We've either eliminated certain things, we've reduced certain things, we've increased certain things, or maybe we've kept certain things. If you want to think out of the box in the application of artificial intelligence, this is often a very productive workshop. All right, our last workshop is rather intensive, so if you need to take a break, I would pause the video here and come back in a few minutes. What is the last workshop? It's called the 5 C's framework. If you're not sure you've covered every possible idea, this framework pretty much covers everything you can possibly do. It has its origins in microeconomics. You may be familiar with something called the demand curve. Basically, there are 2 dimensions. On the horizontal axis, we have the quantity of sales. On the vertical axis, we have the price of products. Clearly, the higher priced a product, the less people will want to buy it. Now, for any given product, we have a price and we have a quantity. That price and quantity basically captures the entire revenue stream of a value chain. At the top of a value chain, you have the raw materials producers. They then sell to manufacturers, who then sell to retailers. As you go through the value chain, the prices go up as a transfer price from one link in the chain to the next. The raw materials charging a price to the manufacturers charging a higher price to the retailers, and then consumers paying a retail price. That final price times the quantity purchased is the entire industry earnings for that value chain. Okay, for the sake of argument, let's assume that I'm a manufacturer and there are 3 competitors at that link in the value chain. I'm the company in the middle marked by a star. Question: what in the world can I possibly use AI for in order to maximize shareholder value? There are literally 5 things you can do. Option number 1, I can compete. I can use AI and machine learning to literally obliterate another company at my link in the value chain. Let's call that a red ocean strategy. Because I'll be able to lower my cost, maybe I can lower my prices and take out a competitor. Option 2, concentrate. This is where you go upstream or downstream in the value chain using artificial intelligence to shift the frontiers within the value chain. Let's think about going upstream. I purchase labor from the labor market. By using algorithms to replace labor, I no longer have to supply from the labor market. Going downstream, if I can use algorithms to potentially create retail or distribution outlets using algorithms or artificial intelligence, I've vertically integrated downstream, capturing some of that value. Option 3, I can price up and down the demand curve. At the highest price, let's call that a premium product, I might be able to create something that is of such high value, I can have a premium price for it. For example, I might be able to create a just-in-time delivery system using robotics that people are willing to pay an extremely high price for. 3 prime, that's a mass market product. 3 prime, that's a factory outlet. It's where the manufacturer disintermediates the retailer by offering a lower price, distributing directly to the consumers. And finally, I can go to 3 prime. This is called gleaning, where you buy directly from the farm. The raw materials people allow you to come to their farm, pick fruit directly off of the farm, thus disintermediating the manufacturers and the retailers. Pricing products and services up and down the demand curve would be called price discrimination by an economist, or, in the 5 C's framework, a capture strategy. Option 4, I can literally shift the demand curve. I can do promotion, advertising, maybe use algorithms to automatically do click campaigns to grow the entire size of the market. Option 5, cooperate. I work with other players in this space to actually achieve one of the first 4 options. Forming a standards committee or something like that that allows products to be interoperable, for example, is a classic application in the tech world. Now, if you don't feel artificial intelligence can achieve one of the 5 C's, then maybe you shouldn't be involved in artificial intelligence at all. In areas that I've worked, one of the most exciting areas of application is reaching the bottom of the pyramid, using very fine-tuned algorithms to reduce the marginal cost of products, especially educational or digital products. You're able to price the product so low, there's no need for the publishing industry. There's no need for other links in the value chain. Reaching the world's poorest people using digital products, for example. Without algorithms, this simply could not have been done. So in many cases, algorithms and AI can fundamentally shift the cost structures of industries, thus allowing people to reach markets that would have been otherwise unserved. Okay, we've just done a lot of brainstorming using many different frameworks and many different approaches. You're going to have a long laundry list of ideas. At this juncture, before you start investing in applications, is you want to prioritize them. So let's do some data reduction if you remember that technology from step 2. A simple data reduction exercise is the following. List every idea and evaluate them on a 1 to 10 scale. 1 means something is very, very hard. 10, super easy. So a high number is a good sign. And then also evaluate each of those options on an impact scale. For example, 1, not very impactful, maybe not a lot of profit. 10, very profitable, very impactful. After you do the scoring, let's just plot it on a 2x2 matrix. By ease, hard versus easy, and impact, low versus high. Clearly, those in the corner, the northeast corner, have high impact and are easy to do. Maybe we should prioritize those first. Then next, we'll do the ones that are kind of in the middle, and then we'll maybe deprioritize those that are extremely hard and frankly don't have much impact. These are called typically investment horizons, doing the northeast first and the southwest last. Consulting firms might label these with different colors and call it a heat map. Okay, now we've actually considered the project options in a portfolio. In order to determine the algorithms after you have identified the actual projects and applications you want to work on, you can refer to the learning journey map, which gives you criteria for choosing the appropriate algorithms. From the algorithms, you'll then go to a code library and you'll do research on what kind of code is available. Once you've discovered the type of code that's applicable to your project, it's at that point you might want to consider changing the team members that will implement this. Sometimes people don't have the appropriate background in the programming language that the application requires. That's something to consider, though, only after you've done the workshops and you've determined the appropriate algorithms. The good news is most of those algorithms can be implemented via R or Python. In addition, there are some Excel spreadsheets where it's very easy to illustrate with your team members how certain algorithms actually operate in a real-time, interactive, and educational manner. The core trick in this process is to use the learning journey map. It will guide you to the most appropriate algorithms given the application that you've decided to work on. I'd like to conclude now with a couple of pieces of advice. Because you've now completed a lot of brainstorming on applications and algorithms, you may want to revisit your objectives and try to map those applications into the objectives. If the applications you originally thought of are not the right ones, of course you'll have to go back and redraw graphical user interfaces, maybe the robots you envisioned. Go back to the beginning and redraft what this project is all about. Only then should you start running the algorithms and estimating models.